Start with f of negative x, and you substitute your negative x. So you get 2 negative x cubed minus 5 divided by what? Negative x. And this, you agree, is negative 2 cubed, and this is plus 5 over x. Ayah.
Okay, I get it.
Alright, so you just factorize x and that's it. What about d? Is it odd, even, or neither? Neither. F of negative x is square root of minus x. What can you do with this except to bring I root x. I is not negative, and I isn't one that could vanish, right? So basically, all we could get is I f of x. If I was negative, then we could conclude that it's odd. But you and I know I is not negative. I square is negative 1, right? And if I is 1, then it means it is even. But we know I is not 1. So it is neither odd nor even, all right? I want to see someone try this before we go. Remember, we go by 11:30 latest, actually 11:28, so you don't get late to the next class. So I need you to stop working in the next 2 minutes. So which of these have you tried? Have you tried this? What do you get? Oh, this is just to show that the difference is odd. Were you able to show that it is odd? Were you able to show that it is odd? Not sure. Please note that, are you giving? You are not supposed to pick specific examples. We've talked about that, alright? If you have picked specific examples, now, remember at this point we prove in general, not specific cases. So if you have done this in general case, please proceed to question 4 and make an attempt. If you have not done it in general case, let's look at the board right now. If you have not done this in general case, please look at the screen right now. Prove that the difference between two odd functions is an odd function. This time around, nothing about f or g. That is where you come in. Let those functions be f and g. Alright? Let the odd functions, I'm talking about these two given what? Let the odd functions be f of x and g of x, but for some f's in the domain of f and domain of g. Alright? After you give them a label, write the property that they meet currently. This implies that f of negative x will be equal to what?
Negative f of x.
Negative f of x. Why do you say that, Leo?
The odd function.
Because f is an odd function. That's all you have to say.
Oh.
Similarly, g of negative x is equal to negative g of x. Right? So this is what we know. So from what we know, we need to prove something. That their sum must be what? Odd as well. All you have to do is do the sum of this. Their sum, that is, you want to check if f of x plus g of x, this is their sum, right?
The difference.
They're different. Oh, sorry. You want to check if this different also satisfy this property, which means if we can put in here. So basically, you want to check, is this odd? That's what you want to prove. That's your goal. To do that, it means if minus is replacing here, we must be able to factorize minus with this same difference. So we start by saying f of negative x minus g of negative x. Do you understand? Which is, do we have something for this? Yes. Minus, maybe I write here, minus f of x, right? There's a minus here, and this g also generates another negative. Okay? which gives minus f of x plus g of x. But what is your goal? Bring minus out. Do we get the difference again? Yes. So which means this difference is an odd function. Does that make sense?
Yes.
You can try this sum. I think the sum is an example in the book. There's a product that is given as an example, as an exercise. That's one of the exercises I will give you, by the way. Has anyone tried this? You want me to give you a homework? Or we do it together in class?
Can we do it together?
Shall we quickly do it together?
Yes.
Nakita, I'll send a picture later. Let's do this together first, because I need you not to be late to your next lesson. F is odd and invertible. This property is the reason why this exists. Understand that? So we want to see if this inverse function is either odd, even, or none of them. That's the point here. Now, since f is odd, it implies that what? F of x, f of negative x, right, must be equal to f of x. We may need that, right? Since f is invertible, oh, I didn't get enough sleep, right? That's what she's going to say. Now, since f is invertible and this exists, can we assume this to be y? Do you still remember our inverse property? If this is equal to y, what can we say from here?
X equals f of y.
Say that again. X equals f of y. Now, we want to see this, right? If this is odd, even, or not. Remember, we are not even going to start here. Our goal at the end is to show that f inverse of negative x will be negative f inverse of x. If we can achieve this, then what is the conclusion? Say that again. F inverse is odd. If this is what we achieve, what do we say? Which means this is your starting point. So the starting point is not here. That's what I'm trying to say. And that is also why we started here in this case. Okay? You always start from what happens when you bring negative in. So let's rewrite this part. Let this left-hand side be y. Then this property holds. Agree? In that case, x will be negative f of y. Agree? What does this lead to? It's something that is given in the question. This can lead to something. You see that? It just changed a variable. This means f of negative p will be negative f of p. This means f of negative 1 million is negative f of 1 million. It's anything. So stop looking for x only. And this is from the question, which means anytime you see this, you could write this. Anytime you see this, you could write it as this. Does that make sense? So what does that imply now? X is equal to f of negative y. What is the reason? Since what? What's the reason? Since f is odd, or an odd function. Does that make sense? Remember, your target is about f inverse, but you came across a property of f itself, which is already given. Does that make sense? So let's see what this can do for us. Well, let's take the inverse back. How do we change it back to the inverse one? Inverse format? Yes? Remember we started with inverse? We went back to f. Now we got something. Let's go back to inverse. Yes, tell me what it is here. Speak louder, please. Make sure x is here so we are not missing stuff.
F of x equals
F inverse of x equals negative y. Does this make sense, everybody? If this is this, then you could take the inverse. Actually, it's like taking the inverse of both sides. X, f of negative y. So if I apply f inverse to both sides, I apply f inverse to f of negative y. What is f times f inverse? This is a composition, remember. It's not many, it's not times. What is the composition of f inverse and f? Come on, we did this. What is the composition of f inverse and f? Anytime. Come on, are you serious? What is the composition of f and f inverse or f inverse and f? This is the only time that the composition is commutative. Say that again. X. Is that what you said? Oh, sorry, I didn't hear that. It gives x. What is the name given to that function? Identity function. And what is identity function? It maps something to itself, right? So it vanishes basically. Because an identity function acting on negative y goes back to what? Speak again. Identity function acting on negative y gives you what? Negative y. Identity function maps an element to itself. Have you forgotten this? Please, you need to remember. So that is why we can write this. Okay? Now what can we do with this quickly because we are kind of late?
Oh, we can do minus f inverse x equals y.
Say that again?
Minus f inverse x equals y.
I don't know where you get minus f inverse. Can you see how I'm arranging this so it doesn't look miserable and confusing? Left maintains left side, right maintains right side. I corrected at the
switch
same
the
way.
minus to the left side.
You bring minus here.
Yeah. Because then it shows that
Oh,
it's
okay.
one function.
Oh, okay. I think I see what you mean. Like this?
Yeah.
But we could do the other way. We could do your substitution even before that, but it's okay. Yes, what do we do next?
And then we can show that the top f inverse minus x equals
Minus f inverse x equals, what is y?
F inverse negative x.
Is this what we want to achieve?
Yes.
So what is the conclusion? So I can change both sides now. I write it as f inverse of negative x equals minus f inverse of x. Therefore, f inverse of x is an odd function. We don't know. Maybe because f is originally odd, that's why we got that. One of the assignment I will give you is, I'll change this to even. Let's see if it is even, odd, or neither. Alright, any questions? I'll take this picture, I send it online, and the video will also be available. Then I will send the question that you need to do as homework. Okay, I'll type it out for you. Alright? Sorry for keeping you waiting.